everyone. Today we're going to see how to predict using the decision tree algorithm. And to do this, I'm just gonna go up to the console and I'm gonna start telling you what every part of the code does. So I installed the packages rpart.plot, depler, and partykit for this program. The dataset that has been used is Iris dataset. It is available for RStudio. You can check it out. It's a fairly nice package. So what I've done is I've read the data first of all, and here is the statement. I've read the data, and as you can see that I checked the head and the tail and saw that all of the species are the first 50 are Iris setosa, then the next 50 are Iris versicolor, and the next 50 are Iris virginica. So I had to jumble up these to get a sample to basically and take away from to have a sample that is random. And so what I have done for that is I've shuffled the data according to the indexes, and gathered all the information in the respective heads of IDs, sepal length, sepal width, petal width, and species, to get a jumbled data frame. So after this, what I do is I remove the ID column from this data and store it in a variable called clean data. Here you can look at clean data. It does not have the ID variable. To split the data into the training and the testing set, I use the splitf function. It's a function made by me, and here is the data. Here is the function body. It's fairly simple to understand, so I'm not going to go ahead into it. So here is the data training set, the training set and the testing set. I've used I've called this splitter function, and I have received a value of 120 for the training set and a value of 30 for the testing set. Just to check if the randomization is correct, Virginica is exactly the same. Versicolor and setosa are somewhat different, but it's +9 over here and +9 over here. So I just gonna 0.9, sorry, 0.09. So I'm just gonna say that it's not a reason to worry, and the randomization is correct. So viewing the training model. So what I do to view the training model is that I use the rpart.plot package, and this is the fit is basically I've used uh, all the variables, identifying variables that are located inside species. Use the training data set and the method class. After fitting this data, I get this particular graph, and these are the probabilities in the graph. And as you can see over here that you can check according to the petal length if it's gonna which species is the data that you have belongs to. I'm gonna use prediction. Now I'm gonna finally show you how to predict data. For that I'm gonna use the library partykit and a variable called myform. Now myform is gonna use this class species, and and it's going to be affected by sepal length, sepal width, petal length, and petal width. So this is the ideal way to write it. I'm going to use the ctree function that is located in the partykit package. It makes things very handy. So here I have the stored all of this I have stored in the ctree, and as you can see I have used the training data over here. So after I have used this, and I use the table um, the table function to get the confusion matrix, which is over here. Now it says that 38 out of 38 setosa plants have been correctly identified. Versicolor versicolor four ver, four versicolor plants have been identified as virginica, and one virginica plant has been identified as a versicolor plant. Now this happens because when the data is actually very similar, so the machine training algorithm is not 100% effective in that case, and this is one of those cases. So after that I have used now over here you can see the what I was talking about. if here is the error percentage shows by how much error is the model predicting what's the differences between the species. So it's fairly easy to understand, and plotting of this function has been done, and you can see it over here that this is the decision tree that was made using these statements. I'm just gonna show you the statements. Yes, just a second. Yeah. So here are the statements that are used to print the following decision tree. You can see that if the petal length is the root node, and from there we see if the petal length is less than 1.9, it for sure belongs to Setosa. There is no error. If it is greater, then we go on to petal width. If now the p-value is less than 0.001, so it's like you're almost sure that in the long run you're gonna achieve these values. If it's less than equal to 1.7, then we go to the petal length, and we see that the p-value has increased slightly, but but the difference is of 0.001, so it's not that significant, and it's obviously still inside the same region. So I'm just going to zoom it so that you can see it clearly. You can see the error rate over here is 2.6, but the error rate here is marginally comparatively very higher. So anyways, this is the decision tree. You can analyze it, and there is the simple code which you can write now. So after this we can see that we can look at our that predict the test set that we had using this particular code, and I'm going to plot it in a table confusion matrix. I'm going to see that the Setosa plants had been correctly identified. The versicolor plants had been correctly identified, and one of the Virginica plants was wrongly identified as a versicolor plant. Now, this was because, as you can see over in the decision tree, since the error rate is high, the prediction was a little off for Virginica, but it's alright. So now we're gonna test the accuracy. Now this is you can see that the particular code uses the table underscore matrix, the diagonal, and divided by the entire sum. So this is going to tell us how accurate our model is, the prediction model, and we can see that it has a 93% probability to predict the right answer. So this is the prediction using the decision tree, and it's gonna give a very accurate it's gonna give an accurate result 93.33% of the times. So thank you.